Good morning, all 100% here. So, first of all, we can see the classifications of load. A load may be defined as the combined effect of external force acting on your body. The load may be classified as dead load, live load. Either it may be called as live load or fluctuating load, inertial load or forces, and next one is centrifugal load of forces. The other ways of classification is tensile loads, second one compressive loads, third torsional and twisting load, and bending load, shear load. This load also may be called as point or concentrated load distributed here. So this is called the point load. A point load or concentrated load is one which is considered to act as a point in the load because contract or generally uh, load. So distributed load, yeah, is distributed or spread in some manner over the length of beam if the spread is uniform at the uniform rate, say per meter or Newton per meter. The uniformly distributed load and is abbreviated as UDL. If the spread is not a uniform rate, it is said to be the non-uniformly distributed load. Triangularly or trapezoidally distributed load fall under the categories. So we can see the stress internal load is called as upon by some loads or external change in shape or dimensions which increasingly materials of the body resist the tendency of the load to deform the body, and when the load influence is taken over by the internal resistance of the materials by a the offers to meet the load is called stress. Uh, uh, Total stress represents the external effect, Newton, kilonewton, or meganewton. The unit resistance developed by a is represented kilonewton per meganewton per meter square. For the stress will be the as simple or direct reclassifications. One is compression and shear stress. Bending or combined. So combinations of 1 and 2. So which is the simple stress called as direct stress, direct loading conditions. Simple compression occurs low is in, and the simple shear and opposite force tends to causes CSR relatively to adjacent. So in stress that develops are not simple stress. For example, the member is subjected to a loading. So we can see here. So the member is subjected to a loading which is perpendicular to the axis of the member. This will cause the member to bend, resulting in deformations of materials and stress being developed initially to resist the deformations. Although three types of stresses are there, so tension that we discussed earlier will develop, but they will not be simple stress since they will were not caused by direct loading. So we can write it as it is the ratio between the load divided by area. So where sigma is the stress and P is the load and A is the area of cross section. If it is noted that in case of either simple tension or simple compression, the areas which resist the load are perpendicular to the direction of forces. When a member is subjected to the resisting area is called as the direction of the forces. Common situations causing shear stress is shown in figure. So here So next one is the strain. Uh, so strain, an element in a material is subjected to stress is said to be strain. The strain is deformations produced by stress. The various types of stress strains are see briefly. So tensile piece of material with a uniform cross section. Piece of material with the uniform cross sections subject to a uniformly axial tensile stress will increase its length. Then the increment of length, which is dl, is the actual deformation of the material. The fractional deformation of the tensile strain is given as the change in length by positional length. Under the compressive force, so under the compressive force, a similar piece of material would be reduced in length. The fraction deformation against gives the strain is the change in length by original length. So shear strain, in case of shear loading, shear strain will produce, which is measured by an angle through which the body dissolves. Next is volumetric strain. So volumetric strain, it is defined as the ratio between the change in volume and the original volume of the body, and is denoted by ERV. So EV is the change in volume by original volume. So since like change in length by original length, so since it is volumetric strain, so we can take by original volume. The strain which disappears with the removal of loads are termed as elastic strains, and the body which regains its original position as elastic body. The body is said to be the plastic. The strains exist even after the removal of the external force. There is always a limiting value of load up to which the strain totally disappears on the removal of load. The stress responding to this load is called elastic limit. So Robert Hooke discovered experimentally that within elastic limit, stress directly proportional to the strain. So shortly we call it as Hooke's law. Stress is directly proportional to the strain. Um, Either it may be so Young's modulus. So Young's modulus equal to stress by strain. So next is Young's modulus. So it is a ratio between so it is the ratio between the tensile stress and tensile strain, or compressive strain by compressive strain. It is denoted as E value. It is same as modulus of elasticity, which is stress by strain. So sigma by E. So next is modulus of rigidity. It is denoted defined as the ratio of shear stress tau to shear strain, and is denoted by C or N or G. It is called as shear modulus of elasticity. Next is bulk or volume modulus of elasticity. It is denoted by K. It is defined as the ratio of normal stress on each face. So on the each face to the volumetric strain, and is denoted by the letter K. So next we can see the